Comparison and analysis of average restaurant inspection scores in New York City. Overview. Problem. The project aims to analyze if restaurants in New York City in proximity to each other share similar inspection scores. Given one manually chosen list of 10 distance restaurants, as well as 10 additional lists of restaurants where each list corresponds to one of the elements in the manually chosen list, we create a bar chart displaying the average inspection scores for all 11 lists. Then we include standard deviation, which helps assess the variation in inspection scores between restaurants that are near and distant from each other. Information source. The restaurant inspection data is obtained from NYC Open Data Restaurant Inspection Results Dataset. Our program takes the latest data recorded up to June 11, 2023, 7:30 p.m. Interest. We found it interesting to explore the extent in which safety and sanitation vary among restaurants in different areas in a city. A lot of these places exist here in Canada, and as we looked at some of these places and their scores, it was shocking to see how many violations these establishments have and how similar sanitation hazards exist likely in restaurants that we go to on a regular basis. Design choices. Function decomposition. We gave top-level functions smaller one task per function helpers. Defining data. We created easy-to-understand data definition and function names. Function composition. We have 9 helper functions that connect to our analyze and main functions. Function reusability. We made some general functions that we could reuse later. Why did we do this? To ensure the code follows HTTF, HTTD, HTTAP recipes and is organized and robust. What will we change? Creating more accurate data definition for zip codes because we said it was an interval of integers when it is actually an enumeration of zip codes. Though this did not affect our program since we have a lot of filtered out data and the program only ran through the zip codes in the CSV. For accuracy in our data definition, we should have made an additional enumeration HTTD.
For the actual problem solving, we started off by making the read function, which would take 3 columns from the data file, and then we manually created a list of restaurant inspection data for restaurants that were found to be far away from each other, and we called it random list. And then we had the main function take in random list and the CSV file name so that the analyze function called show restaurant inspection data bar chart would have access to 2 restaurant lists in total. And then for the analyze function to create the graph, we needed it to create a list of average inspection scores for the y-axis and the restaurant list that we wanted to plot on the x-axis. So we had a top helper function called produce average scores for chart, take care of creating the restaurant list that we wanted on the x-axis by calling a helper function, and then we created the list of average inspection scores by calling on another helper function. And so the rest of the work involved creating helper functions focused on creating the list of sublists or finding the average inspection scores of the sublists in that list. And for creating the list of sublists is a bit more complicated, so this relied on the function list of restaurant inspection data list, which we had store a list with random list as the first sublist inside it, and then we had it call generate random close list to create the other 10 sublists. And so generate random close list took each restaurant in random list together with 10 other close restaurants and put it all together in a list. And so we had helpers like close list and zip code difference determine if the restaurants were close. And then finally we had error bars implemented to solve our problem, and so we used the NumPy library so that we could plot the standard deviation values that we had found using the get standard deviation values function. Finally, we have the graph, which takes at least 4 minutes to load and a lot of painful code, but the first bar we have on the left represents the distance restaurants, and then everything labeled CR represents the close restaurants. And so when we were coming up with the question, we expected that the distance restaurants would have a large standard deviation due to the fact that there would probably be more variety in the inspection scores, while we expected the close restaurants to have smaller standard deviations since we thought that there was a connection between the inspection score and the proximity of the restaurants. But looking at the graph, it does seem that there is no connection between proximity and inspection score since there's so much variety in the standard deviation bars shown in the graph. And for the challenges. So the most challenging aspect of the project was the realization that a lot of helper functions needed to be implemented. So despite initial planning and understanding of the overall structure, we discovered that there were numerous smaller helper functions that were necessary to adhere to the 1 task per function rule. And so this is due to the large amount of data and the desire to create well-organized code. So the planning phase, which involved identifying and defining these helper functions, happened to be the most difficult but crucial step in the project.
What does the future hold? Understanding the problem. Using the HTTD recipe taught us the importance of problem domain and breaking down a question into multiple well-defined definitions, template functions, and examples. In the future, this can be used to understand the elements in the program you want to design. Organization. Using HTTF recipe every time reminded us to decompose a huge problem into smaller manageable tasks and implementing helper functions to ensure readiness and clarity of code. This can be applied to any coding problem so you understand what parameters your function is taking in and when it is retrieving the data from the representation. Use of template comments for the HTTAP recipe allows us to understand the dataset file better and how to focus on function composition when working with the data file. Testing and debugging. Use of examples and tests in every step of the project is important to understand where the code has errors. In this process, you can ensure the code is correct and not producing errors. Graphing. Creating a graph based on the inputs from a large dataset is an important skill in many courses, so learning how to create graphs using systematic program design can make a large and complex dataset more accessible and understandable to others who look at it.